the creation of subsafe lead directly to tougher, and safer, submarines. Another US Navy submarine, Scorpion, was lost in 1968, but there is no conclusive explanation for the sinking. In 2005, the USS San Francisco collided with a sea-mounted maximum speed, an estimated 30 miles an hour at a depth of 525 feet. Subsafe's careful watch over submarine design and manufacture is credited with ensuring the San Francisco not only failed to sink, but that only one sailor died and the ship could even make it back to Guam on its own power. Although the loss of Thresher to Eternal Patrol was a painful one, the reforms undertaken by the Navy ensured the 129 lives lost would not be in vain. In the United States Navy, submarines lost at sea are said to be on Eternal Patrol. One such submarine was USS Thresher. Meant to be the first in a new generation of fast nuclear attack submarines, today it rests in more than 8,000 feet of water, along with its crew. Thresher is one of 2 American submarines lost since the end of World War II. In the mid-1950s, the US Navy was still pushing nuclear propulsion out to the submarine fleet. USS Nautilus, the world's first nuclear submarine, had just been commissioned in 1954, and 9 classes of submarines were created, including the Sailfish, Barbel, Skate and Skipjack classes, before the Navy felt it had a design worthy of mass production. Preceding classes of nuclear submarines were built in small batches, but Thresher would be the first class to build more than 5. Altogether 14 Threshers would be built. The Threshers were designed to be fast, deep-diving nuclear attack submarines. They were the second class, after the pioneering Skipjack class, designed with the new streamlined hull still in use today. They were the first submarines to use high-strength HY-80 steel alloy, which was used through the 1980s on the Los Angeles class. The submarines were just 278 feet long, with a beam of 31 feet. They weighed 4,369 tons, submerged, making them about 30% larger than the Skipjacks. Their S5W pressurized water reactor drove 2 steam turbines, which turned a single propeller to a combined 30,000 shaft horsepower. This gave them a surface speed of 20 knots, and 30 knots submerged. This was a noticeable improvement over the underwater speed of the older Skate class, which could manage only 22 knots underwater. The ship primary sensor was a BQQ-2 bow-mounted sonar, the first bow-mounted sonar in any American attack submarine. This necessitated moving the 4 torpedo tubes amidships, an arrangement that is carried on to this day in the Virginia-class subs. The submarines could carry Mark 37 homing torpedoes, Mark 57 deep-water mines, Mark 60 captor mines and the Subrock anti-submarine weapon. The Thresher would be a powerful addition to the US Navy's submarine fleet. On April 9, 1963, USS Thresher was conducting dive tests 220 miles east of Cape Cod. Though it had been in service for 2 years, the US Navy was still attempting to determine the true strength of its hull. At the time of the incident it was reportedly at a test depth of 1,300 feet, with the submarine rescue ship USS Skylark waiting above. On board were its standard complement of 16 officers and 96 enlisted, plus 17 civilian contractors on board to observe the tests. At 9:13 a.m., 15 minutes after reaching test depth, Thresher reported to Skylark, experiencing minor difficulties. Have positive up angle. Am attempting to blow ballast tanks. Will keep you informed. 2 more garbled messages followed, then a sound like air rushing into an air tank. Thresher was never heard from again. Its hull was found at the bottom of the ocean, under 1.5 miles of water, ruptured into 6 pieces. What sank Thresher? The best available theory is the extensive use of silver brazing on piping throughout the ship. An estimated 3,000 silver braze joints were present on the ship, and the theory goes that up to 400 of them had been improperly made. Experts believe that a pipe carrying seawater experienced joint failure in the aft engine spaces, shorting out one of the main electrical bus boards and causing a loss of power. But a loss of electrical power was only half of the problem. According to Navy testimony provided in 2003 to the House Science Committee, the crew was unable to access vital equipment to stop the flooding. As the submarine took on water, the ballast tanks failed to operate. Investigators believe restrictions on the air system and excessive moisture in the air system led to a buildup of ice in the ballast valves, preventing them from being blown and counteracting the effects of the flooding. The U.S. Navy immediately moved to prevent such a tragedy from happening again. Less than 2 months later it created SubSafe, a program designed to ensure the structural integrity of submarine hulls at pressure and, if an emergency occurred, ensure that the submarine could safely surface. It established submarine design requirements and certified construction procedures as specific as cataloging the source of alloy for each piece of equipment that is SubSafe approved. The creation of SubSafe led directly to tougher and safer submarines. Another U.S. Navy submarine, Scorpion, was lost in 1968, but there is no conclusive explanation for the sinking. In 2005, the USS San Francisco collided with a sea-mounted maximum speed, an estimated 30 miles an hour at a depth of 525 feet. SubSafe's careful watch over submarine design and manufacture is credited with ensuring the San Francisco not only failed to sink, but that only one sailor died and the ship could even make it back to Guam on its own power. Although the loss of Thresher to Eternal Patrol was a painful one, the reforms undertaken by the Navy ensured the 129 lives lost would not be in vain.